I will announce the next speaker in the meantime. It's Stefan Schmidt from the Oniro project. It was on our schedule. We had also Davide Ricci from Huawei, which has presented Oniro in the last years. He couldn't join at the end, and we have this very strict policy that the speakers have to be on stage. We don't allow remote main speakers, and Stefan is able to deliver the talk here from stage. Oh, I see you now. Welcome, Stefan, and the floor is yours for Eddie.
So, I think that's, yeah, okay, that's working. Okay, so as Patrick already said, my name is Stefan. I'm working on the Oniro project, which is an Eclipse Foundation project, and I want to talk especially about the EDDI, which is like a sub-project we are working on. So EDDI is about enabling distributed intelligence in Oniro, and I want to talk a little bit about the status what we are having right now. So I will start with a little bit of an introduction. I will talk about the goals we are having with the project, why we are doing it, what we want to achieve with it basically, the use cases we are having for it. And then I dive a little bit into the current implementation we are having. We're having it for Linux as well as Zephyr. And I will finish up with a roadmap what we are planning on to do next year. And the talk Patrick mentioned before about Oniro in general, so the Oniro 2.0 release, that is later today. So this one is like very on the one specific sub-project, but in general the release, that is at 2 o'clock in the afternoon. Okay, so EDDI. If you really want to take it as an abbreviation or something, you can find ways to make EDDI work and like referencing to enabling distributed intelligence. You have to be a bit creative, but it's working. So I mentioned before, it's an Eclipse Foundation project, and we have an Oniro working group in there. So the Oniro working group has, I think, 9 members currently. Neutech Park is, for example, one of them, but also like Huawei, my employees, and Seco, Synesthesia, and more. And in this regard, we are working together with the university, the Politecnico di Milano, so that the research project working together between Huawei and Politecnico within the Oniro working group, basically. The idea is here to define or to write and implement a middleware with different layers, so that's very general terms of like for software development. It's based to be on an Apache 2 license, so we really embrace all the open source licensing here. It's a C++ code base, but we still take into account like very constrained devices. So as I mentioned before, we have Zephyr as one of our targets, which is like for MCU-based systems like Cortex-M class type of devices, which really have like very little memory and flash and so on. So we need to take that into account when developing with C++, but that's something we can do. The implementations we're having is running on Linux and Zephyr right now, and one word of warning, this is very much work in progress. That is not a final finished product or any product or project I'm presenting here. This is really something we are working together with researchers, with 2 professors from Polyme, trying to understand what we can do in this space, what we can improve, and this is just more like a status update what we are having. Okay, so one of the ideas, one of the problems we have been seeing is that if you have like devices in your home or like even in a car or even in industrial or something, they're mostly like, there's a one-to-one connection. You might have an application to control one specific aspect. You can have like, you need a specific applications to make a picture with a camera. You need to have like, or connect to your doorbell camera or something like that. And our idea was more like, we want to see like a unified pool of resources. So we want to make sure that all the resources that are available within your network, within your home, or even in a virtual network, if you combine that from mobile and so on, you want to have like a unified view on all of them and not only accessing devices what you're having. So that also should work cross operating systems. So it's, as I said, we are starting with Linux and Zephyr here. And we need to make sure that these are working well and can really like transfer between the operating system boundaries, basically. And also one thing we want to take into account is, or we want to be aware of, is that this is not for general purpose resources like CPU or memory right now. That is something we have on the agenda, we are talking about with the professors, but that's nothing we implement right now because all the technical aspects about scheduling and making sure that everything runs smoothly, and the latency that encompasses if you go into network communication, that is really something we not tackling right now. And on top of these virtual resources that are available, this unified pool of resources, we want to have like an intelligent orchestration of all of them. That is where the interesting part really starts. We want to have things that are, for one example we're having is like a camera becomes instantly available on your application. So you have like a doorbell camera or a security camera that is a resource that is available to your mobile device, and then you can use it with your camera application on your phone, as an example, right? You don't need an extra application for that because that's all handled in the middleware already. So one use case that is targeting on that is that, for example, you start a video call on your commute back home, you start on a mobile, then you switch into your car, then you have the dashboard camera or whatever. You're going from there, all the audio switches over, all transparently without any interaction with you. And then you're moving back from your car, going to your house. Again, it switches back to the mobile, and then it might end up in the kitchen TV or on a tablet or in the living room or something like that. All these things can work as long as the middleware has an understanding of what's going on. But it's really complex to orchestrate all these kind of things. I mean, you have a plethora of available resources already in your home, but making sure that you're picking the right choices and making sure that it's very convenient for the user to actually use it, that's very different. And that's one of the research topics we are looking in right now. So if you look at the implementation, the architecture is quite simple, I would say. So it's, you have like services that are offering different APIs to different other layers. These are forming what we call local agent that is sitting on every device which is handling all the communication within the distributed network. And these are forming the virtual devices or super devices out of these local agents. So this is not very, very complex or anything. And then we're having the different layers that are part of the implementation. Currently, what we have running and working is the communication and the virtualization layer. So that is implemented and working. And what we are looking in right now is the intelligent coordination layer forming with the local agent and going forward with that. So that is the current research topic. The communication layer, what we have there, we compared different protocols that are available on the market, especially within view on constrained devices. So we compared MQTT, Zeno, and CoAP. We ended up going with CoAP because they also offer us a flexibility of having like built-in device registry where we can register devices and resources that can be then used on the virtualization layer to actually distribute this knowledge and then query for it and find out what devices are available and use them. This is based on libcoap on Linux and the CoAP implementation on Zephyr. We're running both on IP version 4 and version 6. We're also having it run on low-power wireless communication, which is very much needed if you go for like a sensor use case, if you're like a Windows sensor or something. You want to make sure that this one can run on a very, very small battery for like a year or something, and it's not the same power budget you would have like on your mobile phone or something like that. So that's really where also like wireless becomes important, and this is something where Wi-Fi, for example, can't really work. So as I mentioned, the virtualization layer is already based on the resource directory. That is something we are getting from CoAP already. So what is happening when the new device joins the network, it announces itself per multicast on the network. If there is already a resource directory available, it will register its resources. If there's none, and the device is running on Linux, it will promote itself to be the resource directory for this network. And then all the things getting registered, the other layers can use an API to make access of it. And this will be the base for the decision-making process, the reasoning we are doing on the orchestration later on. So as I said, this is the current focus. We are looking at different ontologies and schemas that are available in different projects or in the industry right now. There are things like WebThings, OCF, Robotics OS, and all the other things. So these are things we are looking at and finding out if they would work for us. And then we want to have use these ontologies to have like the best working execution environment for the use case the user is having. And we're also looking into different coordination approaches. as I said right now, what we're having is a device joins the network. If there's no other resource directory, it will promote itself, but it still means you have one central directory. This is also something we might want to change. Because right now it's the implementation because it's the easiest, but later on having like at least a standby version where if the main directory falls out with power outage or whatever, you can switch over to something else. You have a standby or you can even go the complete peer-to-peer approach. Moving that's another thing we are looking for the next year. And while this is all very theoretical and so on, we actually try to make blueprints and really make to have an implementation and use case we are driving with that. If you go out, there's a booth from the Eclipse Foundation. We have a demo there. In that case, it's a demo with a touch screen and a small door lock, which is controlled over wireless protocol. And that's actually using some parts of the current ADI implementation to actually for the communication and announcing itself. So the door lock basically says, oh, here I'm a door lock, and then we have like these context-aware touchscreen, which is actually listening in and understanding what kind of devices are available. And depending on this context, it will show you different screens, what you can do with this device. For example, in the lock screen, it will show you a keypad where you can open the lock and so on. That's all based on the work we are doing on the ADI project here. Yeah, I mentioned before, we are using OpenThread for very low power protocol to make sure that we can have devices that run on a small battery or something. Yeah. So that's what we're having. So the roadmap, I mentioned before, the focus very much for this year is to finalize our decisions on what kind of schemas and ontologies we want to use if we are going with something that's already established in the industry. Right now we are looking tightly at the OCF, Open Connectivity Foundation, and their OIC implementations because they're also based on corps that could be very valuable for us. We're also defining a JSON way of like how we interact with the devices. Right now we are only describing the resources and making them available, but how to interact with them and so on, that's a different story. So we are defining the payload right now, how to do that. And then starting from next year onwards, the focus is really much on orchestrating all of that, like finding out what the best reasoning techniques would be to really fulfill the needs from the user just based on the device. Right now we're getting all the building blocks in place, but the real interesting part only starts next year when we really make use of that. And then obviously we also want to explore a bit more what kind of different coordination approaches we are going to have here. And with that, I would like to thank you. Again, there's the demo outside where you can go at the booth. There's at least a colleague of mine or a few colleagues of mine that can help you. I will be there as well from time to time. And I have like 2 minutes for questions. Go ahead.
Can you explain me what so outside you show a demo, that means you show a blueprint, and what does this demo do?
Okay, so the demo we are having, it's like different parts. So we have like one setup which is like a door lock basically, like a deadbolt that comes out and would lock the door, which is connected to a small MCU-based system running on Oniro with Sapphire. So that is like, you can control that manually. There's a keypad. That is what you might have as a smart lock at your door or something like that. In addition to that, this device has wireless connectivity. That means we can control it from somewhere else. And what we decided to do is like we have another blueprint in Oniro, which is a CATS, which is context-aware touchscreen. The idea is here to really, depending on the context you are having and using it, it would switch the graphical UI, UX, and so on to make sure that it really fits, that supports you what you want to do at that moment. And what we see there is over the wireless protocol, the door lock announces itself, says, I'm here, I'm a door lock, so you can control me, like in this matter, and then CATS finds that, looks for the resources, and based on this decision, it shows you a screen to actually enter the keypad and so on to open the door lock. So you can do it like on the physical side, but also wirelessly based on the door lock. So this is like the combination of the different blueprints we're having here.
Okay, so the idea, if I got it right, is that through Oniro, all these devices communicate directly to each other without using
there's no cloud or anything involved. That's all local communication. So I mean that's part of the. I mean that's not part of ADI, but that's in general for the Oniro project for privacy concerns and everything. There's always options if a hardware vendor wants to add cloud capability, that's fine. But what we design and what we develop, especially in the connectivity field, is real local communication. So it's like really focus on that you have like all the intelligence there. Also, all the eddy stuff will be based on local decisions. You're not sending any data to the cloud and then getting it crunched there and make the decision back or something. That's all local.
And how do they communicate to each other?
That's using, so for the wireless communication, they're using OpenThread, and on top of that, CoAP as a protocol. And CoAP is basically defining the resources and everything. And then on top of that, we have like the actions we want to do, like open the door lock or like enter the pin or something like that. That is defined in a JSON payload.